Alright, so this question is asking for the force of gravity at a location that's equal to twice the Earth's radius. So first of all, we can crank this out normally. We could simply use our equation and figure out what it is. We know that the force of gravity depends on the two masses involved divided by their distance between the two masses squared. So we know what the force of gravity is on the surface of the Earth. We're trying to figure out what it would be if I double that distance, if I go 2 times the radius away. So instead of being at the surface of the Earth, I go a distance where my overall separation between me and the center of the Earth is twice the radius of the Earth. So we could calculate it. We know one of the masses is the mass of the Earth, the other one is 40 kilograms. We know the radius of the Earth, it's on our formula sheet. I could just double it and square it on the bottom and get my number. But let's use the relationships that we see in the equation to our advantage. This equation is telling us that the force is directly related to the two masses. So in other words, if I double mass 1, I would double the force. If I double mass 2, I also double the force. If I triple both of these, so mass 1 is tripled and mass 2 is tripled, I would get an overall factor of 3 times 3. My force would be 9 times bigger. But let's focus on the radius. We have an inverse relationship between force and radius. As the radius gets larger, the force gets weaker. But it gets weaker by a factor of r squared. So if I double the radius, 2 squared is 4, my force should go down by a factor of 4. So if we use the relationship, we can see that the force of gravity is related to, that's the symbol for is proportional to, 1 over r squared. So if I double the radius and square it, I get 1 over 4r squared. In other words, my force has decreased by a factor of 4. So if I just take my original force and divide it by 4, I'll get my force at that location, 98 newtons.